This gigantic structure, towering 6 stories high, isn't a factory or workshop. It's the powerhouse of the world's biggest LNG-fueled container ship. The engine is so massive inside that technicians can freely walk through it. This titan turns a propeller as tall as a 2-story building. And since it powers a colossal container ship, the amount of fuel it needs is unbelievable. It burns 100,000 liters just to start. Even more astonishing is its fuel tank. It is big enough to hold the equivalent of 6 Olympic-sized swimming pools, storing 20 million liters of liquefied natural gas, LNG. Today, you'll discover how this engineering marvel was created, a mega project that pushed human innovation to its extremes. Welcome once again to GNTV. Ladies and gentlemen, even in the 21st century, 90% of global trade still moves across oceans, from the tiniest items to massive machinery. For perspective, according to Flight Radar, at any given time there are 15,000 to 20,000 airplanes in the sky. But if you check marine traffic, when this video was produced, there were nearly 38,000 cargo ships traveling across the seas. Humanity has already built ships of extraordinary size. Larger vessels could be made, but they would be too big to pass through major canals like Panama or Suez. That's why the race today is not to build bigger ships, but to build more efficient ones. This was the mission of French shipping company CMA-CGM. Their goal was to create the world's largest environmentally friendly vessel, a ship powered by LNG instead of diesel or heavy oil. The ship is 400 meters long, equal to 4 football fields end to end. It is 61 meters wide and approximately equal to Statue of Liberty. Its weight equals 7 Eiffel Towers or 11,500 African elephants, roughly 70,000 tons, and that's without any cargo. Its capacity is enormous, 23,312 containers. If they were lined up one by one, they would stretch for 150 kilometers. But the challenge wasn't just building one huge ship. CMA-CGM required 9 identical giant ships within 2 years. A shipyard in Hong Kong was chosen for this epic task, a 4-kilometer-long industrial city where 6,000 workers from multiple nations work around the clock. Normally, constructing one ship takes 18 months, so how did they manage 9 in 2 years? By using a strategy called block construction. The ship begins with rust-resistant steel, plates. Each ship needed 12,660 of these. They were cut using a laser heated to 18,000 degrees Celsius, more than 3 times hotter than the sun's surface. This beam slices steel effortlessly, like butter. For each ship, 880 kilometers of steel strips were cut. These plates were assembled into giant blocks, some the size of rooms, others as tall as buildings. The smart part is that pipes, wiring, and fittings were installed inside each block before the blocks were joined. The ship's rear is made from 5 enormous blocks weighing 790 tons, equal to 2 locomotive engines. 2 huge cranes lifted them in place. The alignment had to be perfect. Even a millimeter's mistake could cause months of rework. Then came endless welding. Each vessel needed 1,250 kilometers of welds, enough to reach from New York to Chicago or Dallas. Every single weld was inspected because even a tiny defect could fail against the ocean's brutal forces. Now arrives the heart of the ship, its engine. This ship runs on LNG, which is much cleaner for the environment. 99% less sulfur dioxide, 91% less air pollutants, and 20% less carbon dioxide. But storing LNG safely is the biggest challenge of all. LNG must stay at minus 161 degrees Celsius. If the temperature rises or insulation fails, it expands rapidly, a dangerous situation. Since the ship must travel from Asia to Europe without refueling, its tank needed to be massive. So engineers built the largest LNG fuel tank ever created, with a capacity of 18,000 cubic meters, enough to fill 6 Olympic pools, holding 20 million liters of LNG. Building this tank was one challenge. Insulating it from heat was another. Engineers essentially created a giant thermos inside the ship. Multiple insulation layers were installed over 9 months. Leak tests were performed using soap solution, vacuum cups, and bubble detection. Any leak was fixed instantly. Finally, a 1.2 millimeter stainless steel membrane was added. At -161 degrees Celsius, steel shrinks, so the wave-like pattern allows expansion and contraction without breaking. This technology is also used on space stations. After 8 months of work, the world's largest thermos was complete. Then came the engine, the most powerful natural gas engine ever built. Standing 20 meters tall, like a 6-floor tower, it weighs more than 2,000 tons and produces 85,000 horsepower. It is so large that maintenance crews can walk inside it. The engine was delivered to the shipyard in 6 huge sections. Its most vital component is the crankshaft, weighing 220 tons. It was transported using a vehicle with 140 wheels and installed with microscopic precision. The engine uses 12 massive pistons, each 1 meter in diameter. These connect through the crankshaft to the huge propeller. The propeller itself is cast in a single piece, weighs 92 tons, and stands 10 meters tall. The propeller shaft must be perfectly straight. Even the smallest bend would cause vibrations at high speeds. Engineers used a blue dye method to ensure proper fitting. Once the body of the ship was complete, it was painted to shield it from salt water and reduce drag. Each ship required 1 million liters of paint, covering 9,500 square meters, twice the area of Vatican City. At last, the highest block, the bridge, was installed. This is the ship's brain, where the captain and crew navigate. A system called Smart Eyes provides a 360-degree view. After 18 months of intense labor, the first ship, Jacques Sade, was ready. Sea trials lasted 15 days, testing everything: speed, emergency stops, navigation systems, leak detection, and even the giant anchor. A single chain link weighs 300 kilograms, and the entire anchor chain weighs as much as 60 African elephants. The ship passed every test flawlessly. CMA-CGM's dream of low-emission megaships became reality. The shipyard not only caught up with time, it defeated the calendar, delivering all 9 giant ships in record time. This is more than the story of constructing a steel giant. It's a tribute to thousands of workers, their mastery, and their relentless dedication. These megaships are now ready to rule the oceans, cleaner and more efficient than ever.